Here's a past paper question from Edexcel Mechanics 2 module, January 2012. I'm not going to read the question out, so if you haven't already, make sure you have familiarized yourself with the question. For part A, we need to find the value of t, and the t is the time when it passes through the point A. So the journey from O to A is what I'm going to work with. I'm going to start by working horizontally. I could start by working vertically, it makes no difference in this situation. So horizontally, this journey from O to A, well, the initial horizontal velocity is 6. We can tell that from the 6I in the initial overall velocity. So that's 6 is the initial horizontal velocity. There's no acceleration horizontally. The displacement is the distance OB. Remember, we are working horizontally at the moment. And the time is the value we're trying to work out. Because we've got constant acceleration, it's 0, that means it is constant. We can use Suvat's. S equals ut plus half at squared is the one to use here. Sub in everything we have, and we end up with OB is 6t. So looking at the question, we've been told that OB is 2AB. So we can use that later, once we've now worked vertically. So vertically, I'm calling up the positive direction. The initial velocity is 12. We can tell that from the 12j. The acceleration is minus g. I'm calling up the positive direction, so I must have a minus here. And in the journey from O to A, the vertical displacement is the distance OA. The time is the same value of t that we had when we worked horizontally. So t is the same for both these equations. Same Suvat, sub in everything we have, and we get a second equation. Now this is where we're going to use OB is equal to 2AB. So sub everything in. So OB, which was 6t, and then 2 lots of AB. That's the right-hand side of my equation. You can see the only variable here, or the only unknown, is t. G is not unknown. We know g. So this is a quadratic equation in t. Let's tidy it up and make it equal to 0. And then I'm going to factorize it. T is our common factor. And then that tells us that either t is 0, which makes sense, because when t is 0, the object is at O, and if the point A had been at O, then both OA and OB, and in fact AB as well, they'd all equal 0. So that value of t being 0 does make sense, but it's clearly not the one we're looking for. So I've just put here, it is not applicable. Although it's a solution to the equation, it's not the one we want. The one we do want is t equals 18 over g. And with g being 9.8, we get 1.8. It is okay to leave your answer as a fraction involving g. That would be allowed. But if you turn it into a decimal, you must give 2 sig fig, because g was rounded to 2 sig fig. In part B, we're finding the speed of the ball at the instant it passes through A. Speed, not velocity. However, we are going to work out the velocity first. Again, I'm going to work horizontally first. I could work vertically first. It makes no difference. So working horizontally, the journey from O to A, u is 6 as it was before. Acceleration is 0 as it was before. Now we know how long this journey takes. And we want to know the final velocity, which I've called Vx, because it's going to be different to the final vertical velocity. So I'm giving them different names. So here we have Vx is 6. We knew that already because horizontally there's no acceleration. So if the initial horizontal velocity is 6, then it'll be 6 for the whole journey. But that proves it. Working vertically, u is 12 as it was before. The acceleration is minus g as it was before. The time is what we now know. And the final vertical velocity I'm going to call Vy. If the diagram is accurate, this was given to us in the question, we can see the particle is on the way down when it reaches A. So the vertical velocity at A, I'm expecting to be negative. So when we put the numbers in, we do end up with a negative value, and that fits in with the diagram. I think it would be really nasty if an exam question gave you a misleading diagram. Notice here that G cancelled out. I'll come back to that in a moment. So when passing through A, the velocity is 6I. That's the I component is 6. The J component is minus 6. But the question wanted the speed. So unless we turn this into a speed, we're probably going to lose the last 2 marks. Find the magnitude of 6I minus 6J is 6 root 2. Now you can turn that into 2 sig fig if you want to, but because the G is cancelled out, then both this 6 and this minus 6 are not dependent on G. So they're not depending on a rounded number. So you are okay to give an exact answer in this case. In part C, there's another point on the path where the speed is also capital V. Capital V is what we've just found. So there's another point where the speed is also 6 root 2 meters per second. We want to find the time taken for the ball to travel from O to that point. Imagine this journey. We just found at the point A, it's moving horizontally at 6 meters per second and vertically down at 6 meters per second. For another point to have exactly the same speed, then it must have the same horizontal velocity, which is not difficult because that is constant for the whole journey. But importantly, the vertical velocity must be the same. Well, the same number, just in the opposite direction. So it must be a point here. On the way up, before it reached the top and started coming back down, when the vertical velocity was 6 upwards. That's where C must be. So for part C, it must be the point where the velocity is 6I plus 6J. We now want to find the time taken for the ball to travel from O to that point. So we want to work vertically here. There's no point working horizontally. We don't have enough information. You can try it if you want to, but you'll find we just don't know enough things to be able to solve it. So working vertically instead, this is now the journey from O to C. Initial velocity 12, acceleration minus G. The final velocity is 6 upwards, so positive 6. Has to be positive, this 6. And time is what we're trying to work out. I've called it capital T just to avoid any potential confusion with the lowercase t from earlier. V equals U plus AT times these things together, sub in our numbers, and then the time taken, when you simplify, you get 6 over G. You can leave your answer as 6 over G, or you could write it to 2 sig fig 0.61 seconds.